So this is a video lesson for section 9.7. In 9.7, we are going to be looking at problems that are very similar to the problems in 9.6, and mastery of the problem types in 9.6 is essentially required to be able to do 9.7 effectively. So if you're not sure about 9.6 yet, make sure that you go back and look at my videos, both the video lesson and the homework video, and ask me questions, because 9.7, you need to understand 9.6 before you get to 9.7. So let's take a look at three examples that you'll encounter in 9.7. These are easy types of problems. This isn't the most difficult part of 9.7 yet. So let's take a look at the first problem on the very left. You have 3x squared plus 9x minus 12. Looks pretty similar to the trinomial factoring problems we did in 9.6, except we have something in front of that x squared. That's actually new. If you remember in 9.6, when we had our two parentheses, if you remember, we got our two parentheses, and in the first position you would have x on x to get your x times x. Well, you now have that 3 in front of there. You can't just put an x and an x anymore, because you have that 3. That 3 has to go somewhere. Well, what do? Let's take a look at this problem, because we don't actually have to do the difficult parts yet, because you can factor out a 3 out of everything here, right? The 3 goes into the 3, the 3 goes into the 9, 3 goes into the negative 12. So I'm going to factor out this 3. And then inside goes what's left. 3x squared divided by 3, that's x squared. 9x divided by 3, well, that's just 3x. And negative 12 divided by 3, that's a negative 4. Now that we're in this form, we can actually deal with this trinomial. We can factor it easily, because this is just like the trinomial factoring we worked with in 9.6, where you created your two parentheses. The 3 doesn't go anywhere, it's still in front here. And then you would write your two x's, x here, and they come from that first x squared term. Now that the x squared is technically alone, it's just an x and an x. But we already figured that 3 out. And then you get your two numbers that will add up to a 3, yet multiply to a negative 4. And what you want to do there is you want a positive 4 and you want a negative 1, because 4 minus 1 is 3. 4 times negative 1 is negative 4. That's it. You're done. So the only thing we did differently here was factoring out the 3 first to get us into the form that we are now familiar with. Take a look at the middle problem. What's different about that? We have that negative in front of the first term. So just like with the 3, we have to deal with that negative before we can actually put it in this particular form. And how do you deal with that negative? The same way you dealt with the 3. You factor it out. So the negative goes outside. Everything else goes on the inside. Negative a squared divided by negative is a positive a squared. Positive 6a divided by the negative is a negative 6a. Positive 8 divided by negative is a negative 8. The easier way to look at this, if you factor out a negative, everything inside of the parentheses will have its sign flipped in relation to what it was before. Great. So what do we do now? Well, just like before, now that the a is free, where there is nothing in front of it, we can put it into our dual parenthesis mode and factor it out that way. The negative is still outside though, so don't forget about that negative. But now it's nice and simple. You have your a and a in the first position, because they have to multiply up to get that positive a squared now. And then you take a look at the middle numbers, what adds up to negative 6 that also multiplies to negative 8. Well, it has to be 4 and a 2, a combination of those two numbers. So it has to be a negative 4 and a negative 2, except I think I messed up in the original problem I was copying down. I think originally this was a negative 8, which makes sense now. So because negative 4 plus a negative 2 is negative 6, negative 4 times negative 2 is a positive 8. And that's it. That's our problem in a nutshell. And then looking at the last problem on the far right, it's a bit of a combination of the two problems before it. Nothing different yet. Again, we have that negative 2 in front of the x squared. We want the x squared all alone, so what can we do with it? We can factor it out. We factor out that negative 2, and everything else goes inside the parenthesis. So negative 2x divided by negative 2 is a positive x squared. Negative x divided by negative 2 is a positive 4x. And then negative 6 divided by negative 2 is a positive 3. Terrific. So now that we did that, everything else is easy. You write your two parentheses. Negative 2 still goes on the outside, can't forget that. We have our two x's from the first term. And then what adds up to 4, yet at the same time multiplies to 3, well, the only combination that'll work is a positive 1 and a positive 3. 1 plus 3 is 4, 1 times 3 is 3. So those hopefully were simpler problems that will give you a bit of a heads up as to what we are going to be doing in 9.7, because the rest of 9.7 is problem types that look like this, but where you can't factor out the number. So I'll teach you how to deal with those problem types, but make sure you are able to do these problems before we move on any forward. So if you have any more questions with these problems, ask me in class, and especially if you're still a little bit confused about 9.6. So now let's move on to the harder problem types that actually make up the bulk of 9.7. So let's say I gave you this problem. You still have something in front of that x squared. You have that 2, which makes it a bit problematic because we're, again, not very, or at least maybe you're not very comfortable dealing with anything in front of that x squared because it doesn't divide evenly into an x and an x. And now you can't factor it out. Well, that's a problem. Before you could factor that 2 out. Now the only way to factor that 2 out is to get fractions and decimals, and we're going to try to avoid that as much as possible. So how do we do that? Well, let's write our two parentheses, just like before, you know, your two parentheses, and let's see what we can do to factor it out. Well, before you would put an x here and an x here, but that's not going to work now because x times x gives us x squared. And we have a 2x squared. All right. Well, let's see what would happen if this 2 wasn't here. So pretend that 2 is gone, and you're looking just at that problem. Aside from that first term, you would look at the negative 7 and the positive 3. So you would look at the negative 7, and you would look at the positive 3. And then you would figure out what two numbers would add up to a negative 7 and multiply it to a positive 3. I'll give you a hint. Nothing will work because you have to account for that too. But we'll talk about that in just a second. So take a look at this 3 that comes from here. And this is our last term. And remember, we have to multiply to that term. So what are the only factors that will multiply to a 3? Well, a 3 and a 1. 3 times 1 gives us 3. Now, there's no way with mathematics that you can possibly get a negative 7 out of a 3 and a 1. Even if both the 3 and the 1 are negative, negative 3 plus a negative 1, that's negative 4 at best. So you need that too. So now let's take a look at that 2. So I'm going to take a look at that 2 right here. So this 2, the first term 2, I'm going to write it right here. And I'm going to ask you, what terms, when multiplied, will give you a 2? Well, a 2 and a 1 will. So you might be kind of maybe guessing as to what's going to come next. We're actually going to play with these numbers, the 3, the 1, the 2, and the 1, and come up with some kind of a combination here that will make this particular expression work, specifically so we can get to that negative 7. Now, before we do that, let's take a look at the signs. We're multiplying to a positive, yet in the middle we have a negative. So because we have a negative in the middle, at least one of our terms has to be a negative. But because we're multiplying to a positive, both of them have to be negative. The only way to get a positive number is either to start off with two positive numbers or multiply two negative numbers. Positive times positive is positive, negative times negative is positive. But because we have a negative in the middle here, we know we can't have two positive numbers. So the only other recourse is to have two negative numbers. Okay, so that deals with the signs. Then I'm going to write my two x's. I'm going to write an x here. I'm going to write an x here. That comes for this x squared. Now we need to account for that 2. This 2 is made up of 2 and a 1, 2 times 1. So the 2 has to go here, and the 1 has to go here, or in the reverse. The 1 goes here and the 2 goes here. We don't know which way, so it's going to be a bit of a trial and error. I'm going to write the 2 here. I'm going to write the 1 here. And then what about the middle terms, the 3 and the 1? Well, again, we don't know the order. So I'm going to write my 3 here. I'm going to write my 1 here. The number combination is right. The signs are right. I just don't know what order they should go in. Should the 2 go here? Should the 2 go here? Should the 3 go here? Or should the 3 go here? And the only way to figure that out is to put them in some form, FOIL the problem, and see if you can get to a right answer. If you can, they're in the right position. If you can't, you have to do some switching. So let's go ahead and FOIL. 2x times x, that's 2x squared. Good. 2x times negative 1, that's negative 2x. Okay. Negative 3 times 1x, that's a negative 3x. Okay. Negative 3 times negative 1, that's a positive 3. So we got that. Good. We got that. Good. But when we simplify that, we get actually negative 5x. Nope. That's not quite right. Which means while our numbers and our signs are right, the order was not. So let's rewrite this again. We know that the signs have to be negative and negative because they multiply to a positive 3, yet there is a negative in the middle, so there has to be a negative in there. And then we're going to write our two x's. And I'm not going to deal with I'm not going to change the 2. I'm going to keep the 2 in the first position and the 1 in the second position, although you can switch that too. I'm going to switch this first. I'm going to put the 3 here and the 1 here. Okay, let's do that. 1 here and the 3 here. So let's FOIL and see if this works. 2x times x, 2x squared, good so far. 2x times negative 3, that's a negative 6x. Negative 1 times 1x, that's a negative 1x, or negative x. Negative 1 times negative 3, that's a positive 3. When we simplify this, negative 6x minus 1x, negative 7x. Voila, that works. So problems like this, they have a two-step approach. First, you figure out what are the two number combinations. One comes from the last term, the 3 in this case, the 3 and the 1. And the other number combination comes from the first term, the one that's in front of the x squared. It was a 2, so that my number combinations were 2 and 1. And then you figure out your signs. If you end up with a positive, yet you have a negative in the middle, both the signs have to be negative. If you have a negative in the end and a negative in the middle, one of the numbers has to be negative, the other one has to be a positive. And if obviously everything's positive, everything's positive. Let me write you up a quick little key here. So if the original problem looks like this, sorry, my bad. If the original trinomial, let's say it's x squared minus bx plus c, then in your new trinomial, the signs have to be negative, negative. If the original trinomial looks like this, x squared minus bx minus c, so it's minus in the middle and in the last position, then in your new factored form, one of them has to be a plus, the other one has to be a minus. And it's not necessary that the first one's a plus. Those can switch, and sometimes you will have to play with that as well. And if obviously everything is a positive, everything ends up being a positive. But that's your key as well. So if the last position is a positive. Actually, I have to stop the video here.